Good morning. Our lesson today, is about atomic structure of matter. Last session we talked about the structure of the matter. We studied that the matter consists of molecules. These molecules consist of atoms. And today we will talk about the atomic structure of the matter. We talked about the structure of this atom. Okay. Let's start. Let's start with the element. Around us, there are many elements. We have 118 elements around us. So, the chemists, the scientists who study the chemistry use symbols to express element easily. Use symbols to express element easily. I mean. I mean, if there is one element, this element is called iron. If I wanted to, there is one element is called iron. Okay. If I want to write this element, the iron, I can write Fe. Sorry, I can write Fe. I can use symbol instead of the word of the element. Another example, there is another element is called sulfur. Instead of write this word, I can write S. I know the S is a symbol of sulfur. So if I write S, it means sulfur. So the chemist use symbols to express element easily. Instead of the word, I can write the symbol. The symbol represents one individual atom. If I write Fe, I know this is the symbol of iron, but it's the symbol of one atom of the iron, not one atom of the iron. S, one atom of sulfur. Na, one atom of sodium, and etc. Okay, so today we will talk about the atomic structure of the matter. So what is the meaning of the atom? The atom, it is the individual, it is the fundamental building unit of matter. The fundamental building unit of matter. Or it is the smallest individual unit of matter which can share in chemical reaction. It is the smallest individual unit of matter which you can share in chemical reaction. The difference between the atom and the molecules in the previous lesson, we talked about the molecule. The molecule can exist freely. This molecule can exist freely and has the simple basis of the matter. But the atom, we can't find the atom freely. We can't find the atom individually. Okay, but the atoms they can share in chemical reactions. So what is the difference between the molecule and the atom? The difference between the molecule and the atom, the molecule can exist freely, can exist, can exist freely and has the same properties of the matter, but the atom can't exist freely. We can't find the atom individually, but the atom can share in chemical reaction. We deal with matter as atoms in chemical reaction. So what is the meaning of the atom? It is the fundamental building unit of matter, or it is the smallest individual unit of matter which can share in chemical reaction. As I said, the chemist use symbols to express element easily. Okay, so in this table, there are some symbols of some elements, like hydrogen, the symbol of hydrogen is H, the symbol of potassium is K, oxygen O, bromine Br, aluminum Al, chlorine Cl, beryllium Be, magnesium Mg, nitrogen N. This is this is the table that has the symbols of some element. You must know this element or these symbols of the element well. You must know this element well. From this table, we can conclude some things. From the previous examples, we find that the symbol of element may be 1 liter or 2 liters, like hydrogen 1 liter, chlorine 2 liters. So the symbol of element may be 1 liter or maybe 2 liters. If the symbol of element 1 liter, you must write this element in a capital. Okay. If the symbol of the element 1 liter, you must write it in the capital. If you write it in the small way, this is wrong. This is not the element. Okay. If it is 1 liter, it is written in capital, like carbon symbol. Symbol of the carbon is C. So 1 liter, you must write it in the capital like this. Carbon. Oxygen. Oh, 1 liter, you must write it in the capital. Um, Hydrogen H, you must write it in the capital because it is 1 liter. Okay. There are 2 liters. There are some symbols that is written in 2 liters. Okay. If the symbol is 2 liters, the first liter is written in capital and the second liter is written in small, like sodium. Sodium, the symbol of sodium is Na, so it consists of 2 liters. The first liter is written in capital and the second liter is written in small, so the symbol of the sodium is Na. If you write the sodium, this is the symbol of the sodium. Okay, Na. The first letter is capital, the second letter is small. If you write the symbol of sodium is in A, small and small, this is wrong. If you write it in A, the first is small and the second is capital, it is wrong. This is not sodium, but the sodium, it is consists of 2 liters. The first liter is capital, the second liter is small. Okay. Why we write some element in 2 liters? Can we write all elements in 1 liter? No. Why? Because some elements are common in their first liter. So the second liter is taken to differentiate. So why we write some elements in 2 liters? Because some elements are common in their first liter. So we can differentiate between them by the second liter, like carbon and calcium. Carbon, the first liter is C. The first liter is calcium is C. So we can differentiate between carbon and calcium. We write carbon in 1 liter, like C, and we write calcium is 2 liters, Ca. So the second liter differentiate between carbon and calcium. Another example, sulfur and silicon. Sulfur, the first liter is S. Silicon, the first liter is S. So we can differentiate between them both. The second liter. The second liter is small, so we can differentiate between them. Hydrogen and helium. The first liter is H. The first liter is H. So we can differentiate between them both. We use with the hydrogen 1 liter is H, and we use with the helium is 2 liters. The first liter is H, and the second liter is E. Okay, you must know this. You must know this table well. You must know this table well. I can ask you fluorine. What is the symbol of fluorine? You will tell me F. Magnesium Mg, chromium Cr, sulfur S, hydrogen H. So you must know these elements well. These elements is derived from its Latin name, so not English name. I said that the symbol of sodium is Na. Sodium is Na. So if you ask me, Miss, sodium is started with S. Sodium is started with S, the letter S, but we write it as Na. Because sodium is English name. It's English name, but deuterium it's Latin name, and the symbols derived from the Latin names or Latin language, not English language. So the symbol of sodium is Na, not S. Another example, potassium. Potassium, the English name. Calcium, the Latin name. So the symbol of potassium is K. Why? Because it is derived from Latin name, not English name. Iron. Iron is the English name. Ferrum, its Latin name. So Fe. Why? Because it's derived from Latin name, not English name. Copper and cadmium. Copper English, copperum Latin name. So Cu, it is derived from Latin name, not English name. Argentium and silver. Silver, it is an English name. Argentium is the Latin name. So Ag, it is derived from Latin name, not English name. So the symbols, all symbols of element derived from its Latin name, not English name. So helium, He, what? Because helium English name, it's English name and it's Latin name. So it is derived from Latin name He. Hydrogen in Latin like English. So the symbol of it is hydrogen. Okay, so I said this table is you must use the symbols very well, and you must know the symbols can be written in 1 liter and 2 liter. 1 liter in capital, 2 liters. If it is 2 liter, the first liter is capital, the second liter is sodium. The symbols of elements derived from its Latin name, not English name. Now we will talk about in the very important point in this lesson and very important point in science. The atomic we will study the atomic construction of any element, and in the next session we will talk about the electronic distribution. Now we will talk about the atomic construction. Okay, uh, any element consists of molecules, and any molecule consists of atoms. Okay. Now we will talk about the structure of the atom. Structure of the atom. Okay. The atom consists of two parts. The first part is called nucleus, and the second part is called sorry, structure of the atom consists of two particles. This is called nucleus, and okay. So any atom consists of two parts. Two parts. This is called nucleus, and there are another part is called electrons revolve around revolve around the nucleus in a place called orbits. Okay, so the atom consists of two parts. The first part is a nucleus, and around the nucleus there are electrons that revolve around the nucleus in fixed orbits. Okay, let's start with the nucleus. This is called the nucleus. Okay, the nucleus consists of two particles, protons and neutrons. Protons and neutrons. The protons have positive charge and the neutrons have neutral charge. What is the meaning of neutral charge? Neutral charge like this, uncharged. Neutral charge is uncharged. So the nucleus consists of two particles, protons and neutrons. Protons is positive charge and the neutrons is neutral charge. Okay, so this is the nucleus. Again, this is the nucleus. Nucleus consists of two particles, protons and neutrons. The symbol of protons is B and the symbol of neutrons is N. Protons have positive charge. Neutrons have neutral charge. What's the meaning of neutral charge? Neutral charge and charged. Neutral charge mean and charged. Okay, this is the nucleus. Around the nucleus there are electrons. This is called electrons. This is called electron. The charge of the electrons is negative charge. Okay, this is the atom. So the atom consists of two parts. The first part is the nucleus, and the second part is electrons. The nucleus its location. It is in the central core of the atom. This is called the nucleus. Okay, this is the nucleus. This is the nucleus. Okay, the nucleus. It is in the central core of the atom. It is the central core of the atom. Okay, and but the electrons, this is called electrons. Electron. The electrons revolve around the nucleus in fixed orbits at very high speed. This is called the orbit. And inside the orbit, there are electrons that revolve around the nucleus in fixed orbits. The charge, as I said, it is positive charge. Nucleus positive charge. Why it is positive charge? Because it has two particles, the protons that has positive charge and the neutrons have a neutral charge. So the charge of a nucleus is positive charge. But the charge of electrons is negative charge particles, and the number of electrons equals the number of protons in the neutral atom. The number of electrons equals the number of protons in the neutral atom. What's the meaning of the neutral atom? The ordinary atom. As Allah find it the neutral atom, the ordinary atom, and the neutral atom, the number of electrons equal the number of protons. Okay, this is the charge. So the location. So I said the atom consists of two parts, nucleus and the electrons. Nucleus, the center of nucleus in the central core of the atom. This is called the nucleus. Electrons, there are electrons revolve around the nucleus in fixed orbit. This is electrons, this is electrons, this is electrons, this is electrons. Revolve around the nucleus in fixed orbits. Okay, this is the location. The charge of the nucleus is positive charge. Why? Because it has protons that positive charge and the neutrons that is a neutral charge. So the charge of the nucleus is positive, but the charge of electrons is negative. Electrons is negative charge, and this and there is the information in that electrons, the number of electrons equals the number of the protons in the neutral atom. The mass, the mass of the atom is concentrated in the nucleus. The mass of the atom concentrated in the nucleus. Why? Because the mass of electrons is very small. The mass of electron is very small relative to the mass of the proton and to the neutrons. So we can negligible the mass of electrons. So the mass of the nucleus concentrated in the nucleus. Why? Because the mass of electrons is very small, can be negligible relative to the mass of the proton and neutrons. Okay. So what is the mass of the atoms? The mass of the atom concentrated in the nucleus. Why? Because the mass of the electron is very small relative to the mass of the protons and neutrons. Okay, this is the structure of the atom. So the atom consists of, this is the structure of the atom. Okay, this is the atom. The atom consists of two parts, nucleus and electrons. Let's draw it again. Let's draw the atomic structure or the structure of the atom. Let's draw it. The atom consists of two parts. The first part is nucleus. The second part is electron. Electron which revolve around the nucleus in fixed orbit. So this is nucleus. This is called the nucleus. And this orbit. Inside the orbit, there are electrons that revolve around electrons that revolve around the nucleus in fixed orbit. Inside the nucleus, there are two parts, protons and neutrons. So inside the nucleus, there are two particles, proton and the neutrons. The protons is positive charge and the neutrons is neutral charge. Neutral charge mean uncharged. So the charge of the nucleus is positive charge. Why? Because the nucleus has protons that are positive charge and the neutrons that are neutral charge. So the charge of the nucleus is positive charge, but the charge of electrons is negative charge. Okay, and the number of electrons that revolve around the nucleus equals the number of protons. Number of electrons equal number of protons in ordinary state or in the neutral atom. Okay, this is the structure of the atom and the mass of the atom concentrated in the nucleus. Why? Because the mass of electrons is very small according relative to the mass of the protons and the mass of protons and the neutrons, so we can negligible it. So what is the charge of the atom? I said that the charge of a nucleus is positive, the charge of electrons is negative, and the number of electrons is equal to the number of protons. So the charge of the atom is neutral. The reason that the atom is electrically neutral in its organic state. Why? Because the number of negative electrons which revolve around the nucleus is equal to the number of positive protons inside the nucleus. The number of electrons or the number of protons, which is positive, is equal to the number of electrons, which is negative. So the number of positive charge equals the number of electron charge. So there are the atom neutral in its ordinary state. The reason the atom is electrically neutral in its ordinary state because the number of protons which are positive charge equal to the number of electrons which are negative charge. Okay, To express an atom of any element, we use two terms. Okay, I said that the atoms is the symbol of atom. We can write the element as by using the symbol, and each symbol represent one individual atom. So if I wanted to write oxygen, I write O. I know it is oxygen. If I wanted to write sodium, I write in A. So it is a sodium. If I wanted to write sulfur, I write S. If I wanted to write calcium, I write Ca. Okay, this is the symbols of some element. But we use two numbers of each element. We use two number of each element. This number, any element has two numbers. This number is called the mass number and the atomic number. So we have two numbers of any element, mass number and atomic number. Mass number, mass number, it is the large number. Okay, it is the largest number. It is written above the symbol at the left side. We written it above the element at the left side. Mass atomic number, it is written below the symbol on the left side, below the symbol of the left side. Okay, so it is above, it is mass number. Below, it is atomic number. So what is the meaning of mass number and what is the meaning of atomic number? This is mass number and this is atomic number. What is the meaning of mass number and what is the meaning of atomic number? The mass number, it is the largest number, so it is the sum of, or the total of the number of protons and the neutrons in the nucleus of an atom. The mass. I said the mass of the atom is concentrated in the nucleus, so the mass of the atom, it is the mass of the nucleus. What's the meaning of the mass of the nucleus? Means the number of protons and neutrons. So the mass number, it is the sum of the number of the protons and the neutrons in the nucleus of an atom. Okay, this is the mass number. What is the atomic number? The atomic number, it is the number of protons in the nucleus of an atom, number of protons. And I said the number of proton equals the number of the electrons in the ordinary state. So atomic number, it is the number of protons in the nucleus of an atom, or it is the number of electrons not in the ordinary state. But the main definition, atomic number, the number of protons in the nucleus of an atom. So Al, aluminum, has two numbers, 27 and 13. 27, it is the above number, so it is the mass number. 13, it is the below number, so it is atomic number. 27 means the number of protons and the number of neutrons equal 27. 13 means the number of protons inside the nucleus equal 13. So what is meant by the atomic number of calcium atom equals 20? This means that the number of protons in the nucleus of calcium equals 20. Why? Because the atomic number, it is the number of protons. What is meant by the mass number of calcium atom equals 40? I mean the total number or the sum number of the numbers of protons and the neutrons inside the nucleus of calcium atom equals 40. So if I ask you what is the meant by atomic number, you will tell me the number of protons equal. If I ask you what is meant by mass number, you will tell me the total number of protons and the neutrons equal this number. So from this information, we can conclude that the atomic number equal number of protons and the number of electrons, but in the ordinary state of the atom. This is the atomic number. The mass number equal the mass number. It is the largest number. So it is the sum of number of protons from number plus number of neutrons. So if you want to calculate the number of neutrons, the number of neutrons equal mass number minus atomic number. The mass number minus atomic number. The mass number is always larger than the atomic number. Why? Because the mass number, it is the number, or it is the sum of numbers of protons and neutrons, but the atomic number, it is equal the number of protons only, so the mass number is always larger than the atomic number. Write the symbol of the following element. Let's answer some questions. Sodium, the symbol of sodium is Na. Potassium, the symbol of potassium is K. It is 1 liter, so I write it in the capital. Sodium is 2 liters, so I write it the first in capital and the second in is a small. Chlorine, Cl. The first in capital and the second is a small. Nitrogen, N. 1 liter is written in capital. Calcium, Ca. The first liter in capital, the second liter is in small. Aluminum, Al. The first liter in capital, the second liter is a small. So these are the symbols of some elements. The nucleus of or hydrogen, it is the symbol of hydrogen. Hydrogen is H. The atomic number is 1, the mass number is 1. Why? Because hydrogen has no neutrons. The number of neutrons is 0. The number of neutron equals 0. So its atomic number equal its mass number. So it is the only element that the atomic number, that its atomic number equal its mass number. Why? Because the number of neutrons inside it is 0. The number of neutrons, the hydrogen doesn't contain any neutrons. The number of neutrons is 0. So the atomic number, its atomic number equal its mass number. The number of neutrons may be equal the number of protons or larger than the number of protons. Carbon C6, well, the atomic number is 6. The number of protons is 6. And its mass number is 12. So the number of neutrons equal 12 minus 6 equal 6. So the number of protons equal 6. The atomic number 6, so the number of protons equal 6, and the number of neutrons equal 6. So the neutrons may be equal to the number of protons. Another example, the number of protons, sodium, the number of protons in sodium equals the atomic number. Its atomic number is 11, so the number of protons is 11. The number of neutrons equal mass number minus atomic number, so equal 23 minus 11 equal 12. So the number of neutrons may be larger than the number of protons. So if the number of a proton change, what will happen? The value of positive charge will change. Why? Because the proton's positive charge, so the value of positive charge will change. The proton is the atomic number, so the value of the atomic number will change, and the mass number will change. Why? Because the mass number depends on the protons, because the mass number equal proton plus neutrons. So if the protons, the number of protons will change, the positive charge will change, the atomic number will change, and the mass number will change. So the element will change into another element. So it becomes another element. Why? Because if the number of protons it change, there is or this becomes another element. This becomes another element. Okay. And the next session we will answer another examples of atomic number and mass number.